Hello, and welcome to tonight's celestial journey. I'm the drowsy professor, your guide through the quiet cosmos. As you settle beneath whatever moon may be shining above you tonight, let me know where in the world you're stargazing from and what time it is in your corner of the universe. Now, find your most comfortable position. Imagine the gentle pull of lunar gravity slowly releasing its hold, and let's drift together into a world where the night sky holds different mysteries. Chapter 1. The Silent Departure. Picture yourself standing in your backyard on a perfectly ordinary evening, the familiar comfort of twilight settling around you like a soft blanket. The air carries that gentle coolness that comes just after sunset, when the day's warmth begins to fade and the first stars start to appear in the deepening sky. You've looked up at this same sky thousands of times before, always knowing exactly what to expect. The gradual appearance of stars, the familiar constellations taking their appointed places, and there, rising majestically over the horizon, the moon in whatever phase it happens to be wearing tonight. But tonight is different, though at first you don't realize it. The sunset unfolds exactly as it always has, with soft oranges and gentle purples painting the western sky. The familiar sounds of evening surround you, the distant hum of traffic settling into its nighttime rhythm, the soft rustling of leaves in the evening breeze, perhaps the gentle call of a night bird beginning its evening song. Everything feels exactly as it should, peaceful and predictable in the way that brings comfort to the end of another day. As the sky darkens further, you find yourself automatically looking toward the place where the moon should appear. It's become such an ingrained habit, this checking for the moon's presence, that you hardly think about it consciously. Your eyes scan the darkening sky, searching for that familiar glow that has accompanied human evenings for as long as our species has existed. But tonight there's simply nothing. The space where the moon should be remains empty, filled only with the deep blue-black of space and the gradually emerging pinpoints of starlight. At first, you assume the moon is simply hidden behind clouds, though the sky appears remarkably clear. Perhaps it's rising later than usual, or maybe it's in a new moon phase and simply too dim to see yet. These rational explanations comfort you as you continue your evening routine, though something in the back of your mind notices that the darkness seems different somehow, deeper, more complete than you remember from other moonless nights. As the hours pass and true night settles over the landscape, the absence becomes undeniable. Where there should be the familiar silver disk, or even the faint outline of crescent, there is simply empty space. The stars, freed from competition with lunar light, begin to shine with unusual brilliance, their light seeming sharper and more defined than you've ever noticed before. The Milky Way, usually visible only as a faint smudge in most locations, starts to emerge with startling clarity, a river of light flowing across the celestial dome that suddenly seems vaster and more mysterious than ever. The silence of this absence is perhaps the most striking thing. Not that the moon makes any sound, of course, but its presence has always provided a kind of visual anchor for the night sky, a familiar friend whose phases marked the passage of time in the most gentle way imaginable. Without it, the night feels untethered, as if the sky has suddenly become infinite in a way that it never was before. The darkness between the stars seems deeper, more profound, filled with possibilities that the familiar comfort of moonlight had somehow kept at bay. As you stand there in this new kind of night, you begin to notice how the absence of the moon affects everything around you. The familiar landmarks of your neighborhood, usually softly illuminated by reflected moonlight, now exist only as dark silhouettes against the star-filled sky. The gentle silver that usually bathes gardens and trees and rooftops is gone, replaced by the pure, clean darkness that allows the stars to claim dominance over the night in a way they haven't been able to do for billions of years. The quality of this darkness is remarkable, not harsh or frightening, but profound and peaceful in its completeness. It's the kind of darkness that existed on Earth before humans learned to create artificial light, a primordial darkness that speaks to something deep in our evolutionary memory. Your eyes begin to adjust to this new reality, pupils dilating to drink in every available photon of starlight, and gradually you start to see the night world with a clarity that the presence of the moon had always prevented. Objects that were previously washed out by moonlight now reveal subtle details visible only in pure starlight. The texture of tree bark becomes apparent in the gentle illumination from countless distant suns. The surface of water, whether in pools or streams, reflects the stars with a clarity and sharpness that creates the illusion of looking down into deep space itself. Gardens and pathways that were merely pleasant under moonlight now possess an almost magical quality, as if the removal of that familiar illumination has revealed hidden dimensions of beauty that were always there, waiting to be discovered. The night sounds seem different too, though at first you can't quite identify why. Birds that usually sing in the gentle glow of moonlight have fallen silent, not from fear, but from a kind of confusion, as if they're uncertain how to navigate this new acoustic landscape. The rustling of small creatures through undergrowth seems both more noticeable and more tentative, as if the animals themselves are slowly realizing that something fundamental has changed in their world. But there's no panic in this change, no sense of disaster or loss. Instead, there's a gradual recognition that the world has simply become different, not worse, not better, just transformed in ways that will require new kinds of attention and adaptation. The absence of the moon feels less like a loss and more like an invitation to discover what Earth's nights are like when lit only by the combined light of distant galaxies and the faint glow of planets that still continue their ancient orbits around the sun. As the night deepens further, you find yourself staying outside longer than usual, drawn by the novelty of this transformed darkness. The air feels different on your skin, not cooler or warmer necessarily, but somehow more immediate, more present. Without the soft buffer of moonlight, the night seems to press closer, creating a sense of intimacy with the cosmos that the familiar presence of the moon had somehow prevented. The stars themselves seem to be celebrating their newfound prominence, twinkling with unusual intensity in the clear, moonless sky. Constellations that were often washed out by lunar light now stand forth with remarkable clarity, their mythological shapes suddenly obvious in ways they never were before. The Big Dipper, Orion, Cassiopeia, all the familiar star patterns seem larger and more defined, as if they're grateful to finally have the stage to themselves after billions of years of sharing billing with Earth's former satellite. This first night of the moonless world passes peacefully, filled with wonder rather than worry. As dawn approaches, the stars begin their familiar fade into the growing light of sunrise, and the world prepares to experience its first day in this new era. The sun rises exactly as it always has, its light unchanged by the absence of its former orbital companion. The familiar warmth spreads across the landscape. Birds begin their morning songs, and life continues its ancient rhythms, adapting with the remarkable resilience that has allowed it to survive countless changes throughout Earth's long history. But something fundamental has shifted. As you finally head inside with the coming of dawn, you carry with you the memory of that profound darkness, that sense of a night sky as a vast, star-filled ocean stretching infinitely in all directions. The moon's silent departure has opened a door to a different kind of night, one that will require new ways of seeing, new rhythms of living, new relationships with the cosmic environment that has suddenly become both more mysterious and more immediate than it ever was before. The transformation has begun, not with catastrophe or chaos, but with the simple, profound change of a familiar presence stepping quietly out of the cosmic dance, leaving behind a world that must now learn new steps in its eternal waltz with the universe. Chapter 2. When Darkness Deepens. As the days turn into weeks following the moon's quiet departure, you begin to notice how profoundly the character of night itself has transformed. The darkness that settles over the world each evening is unlike anything humanity has experienced in recorded history. Not the partial darkness of cloudy nights, or even the deepest shadows of a new moon, but a complete, enveloping darkness that seems to breathe with its own ancient rhythm. Picture yourself stepping outside on one of these early moonless evenings, perhaps 3 weeks after that first night of absence. Your eyes, like those of everyone else on Earth, have begun the gradual process of readjusting to this new reality. The human eye is remarkably adaptable, and already you can see more clearly in pure starlight than you ever imagined possible. Objects that would have been invisible to you a month ago now reveal their shapes and textures in the gentle illumination provided by countless distant stars. The quality of this darkness is extraordinary. It's not the harsh, artificial darkness created by turning off electric lights, but something far more profound and natural. It's the kind of darkness that existed on Earth for billions of years before the moon formed, a primordial night that speaks to something deep in the evolutionary memory of every living thing. As you stand in your garden or walk down a familiar street, you begin to understand that you're experiencing something that no human being has ever known: the true night sky of an unmooned world. The stars have become the undisputed rulers of the night, and their reign is magnificent. Without competition from lunar light, even modest stars that were previously invisible now shine with remarkable clarity. The Milky Way, which most people living in areas with any light pollution had never seen clearly, now dominates the sky like a great river of light flowing from horizon to horizon. On clear nights, the galactic center rises like a glowing cloud of stellar fire, and for the first time in human history, people in urban areas can see the cosmic environment that surrounds our solar system. Astronomers and stargazers find themselves in an unprecedented golden age. Telescopes that previously struggled to reveal faint celestial objects now show details that were impossible to observe when competing with moonlight. Amateur astronomers discover that they can see galaxies, nebulae, and star clusters that were previously visible only through professional equipment at remote observatories. Children growing up in this new world will have a relationship with the cosmos that is fundamentally different from any previous generation. They will know intimately the vast stellar environment that surrounds Earth, seeing it clearly with their own eyes rather than just learning about it from books and pictures. The transformation of human sleep patterns begins gradually but inevitably. For millions of years, human circadian rhythms evolved in the presence of lunar cycles, with the moon's phases providing subtle but important cues for the timing of rest and activity. Now, without those gentle monthly variations in nighttime illumination, sleep patterns begin to shift towards something more fundamental: the simple rhythm of sunrise and sunset, unmodified by any other celestial influence. Many people find that they sleep more deeply in this profound darkness. The complete absence of light that previously filtered through curtains and blinds creates sleeping conditions that promote the deepest stages of rest. Scientists studying sleep patterns in this new world discover that people are experiencing more REM sleep, more vivid dreams, and waking more refreshed than they had in the presence of even indirect moonlight. The darkness seems to embrace sleepers like a gentle blanket, providing the kind of rest that modern humans hadn't experienced since before the invention of artificial lighting. Night shift workers and others who must remain active during the dark hours find themselves adapting in interesting ways. Without the subtle illumination that moonlight provided, they become more dependent on artificial lighting, but also more sensitive to the natural rhythms of starlight. Many report that they can sense the passage of time by observing the slow rotation of constellations across the sky, developing an intimate familiarity with stellar movements that allows them to navigate the night hours with surprising accuracy. The nocturnal animals of the world face their own adjustments to this deeper darkness. Creatures that relied on moonlight for hunting or navigation must develop new strategies, but nature's adaptability proves remarkable. Owls and other night hunters find that their prey animals are equally disadvantaged by the increased darkness, maintaining the predator-prey balance that has existed for millennia. Many nocturnal species actually benefit from the deeper darkness, finding it easier to avoid detection by predators and to move unseen through their territories. Bats, those masters of night navigation, continue their aerial hunts with little change in their behavior. Their sophisticated echolocation systems were never dependent on visual cues, and the absence of moonlight has no effect on their ability to navigate and hunt with precision. If anything, some species seem to benefit from the reduced activity of birds that were more dependent on visual navigation, finding less competition for aerial insects during the darkest hours. The behavior of domestic animals begins to shift in subtle but noticeable ways. Cats, with their excellent night vision, become even more active during the dark hours, taking advantage of their superior ability to see in conditions that challenge other creatures. Dogs seem to rely more heavily on their senses of smell and hearing, developing enhanced awareness of the night world around them. Many pet owners notice that their animals seem calmer and more relaxed during the deeper darkness, as if the profound night provides a sense of security that lighter evenings never offered. Gardens and natural areas take on entirely new characteristics under pure starlight. Plants that depended on moonlight for certain growth cycles must adjust their rhythms. But most vegetation adapts with the remarkable resilience that has allowed plant life to survive countless environmental changes throughout Earth's history. Night-blooming flowers, which evolved to open under moonlight, gradually shift their timing to respond to other cues. Perhaps the rising of certain constellations or subtle changes in temperature that occur during different parts of the night. The absence of moonlight reveals aspects of the natural world that were previously hidden. Bioluminescent organisms, fireflies, certain fungi, marine plankton, become much more noticeable and seem to glow with unusual intensity against the dark background. These living lights take on new importance in the nighttime ecosystem, providing the only significant illumination in areas far from artificial light sources. Fireflies in particular seem to thrive in the deeper darkness, their mating displays becoming more elaborate and noticeable than ever before. Human communities begin to adapt their evening routines to accommodate the changed conditions. Outdoor lighting becomes more important in populated areas, but many people discover a preference for minimal illumination that allows them to maintain awareness of the spectacular night sky overhead. Restaurants and gathering places develop new approaches to outdoor dining and evening entertainment, often featuring subtle lighting that enhances rather than competes with the cosmic display above. The psychological effects of these deeper nights prove to be largely positive. Many people report feeling more connected to the natural world, more aware of Earth's place in the larger cosmos, and more appreciative of the spectacular stellar environment that surrounds the planet. The nightly display of stars, galaxies, and cosmic phenomena becomes a source of wonder and inspiration that enriches daily life in ways that the previous lunar-illuminated nights never quite achieved. Children adapting to this new world show remarkable resilience and curiosity. Those old enough to remember moonlit nights often express initial concern about the darker evenings, but younger children seem to accept the star-filled darkness as perfectly natural. Many develop an early fascination with astronomy, learning to identify constellations and planets with an accuracy that previous generations rarely achieved. The profound darkness becomes, for them, simply the natural state of night, a time when the stars come out to play across the vast cosmic playground overhead. Artists and photographers discover new possibilities in this transformed night environment. The pure starlight creates shadows and illumination effects that were impossible when moonlight dominated the darkness. Long exposure photography reveals details of the night landscape that were previously invisible, while painters and other visual artists explore new ways to represent the profound beauty of truly dark nights illuminated only by distant stars and galaxies. Writers and poets find inspiration in the deeper mysteries that this darkness reveals. The night sky, no longer softened by the familiar presence of the moon, seems to pose more profound questions about humanity's place in the universe. The vastness of space becomes more immediate and obvious when viewed without the comfortable, nearby presence of Earth's former satellite to provide a sense of scale and familiarity. As weeks turn into months, communities develop new traditions and customs around the changed character of night. Star-watching parties become popular social events, with people gathering to share telescopes and knowledge about the cosmic display overhead. Evening markets and festivals adapt to the deeper darkness, often becoming more intimate and magical as they work with rather than against the profound night that now defines Earth's evening hours. The transition continues gently, without trauma or catastrophe, as life on Earth demonstrates once again its remarkable ability to adapt to changing conditions. The deeper darkness that has replaced moonlit nights proves to be not a loss, but a transformation, an opportunity to experience the night sky as it existed for billions of years before the moon's formation, and as it might exist on countless other worlds throughout the galaxy where the cosmic dance includes only stars and planets, unaccompanied by the gentle, silver light of a large natural satellite. This new relationship with darkness becomes part of the rhythm of daily life, creating a world where night means something different, something deeper, and more connected to the vast cosmic environment that has always surrounded Earth, but was somehow made less obvious by the familiar, comforting presence of the moon. Chapter 3: The Calming of Waters. As the months pass in this moonless world, perhaps the most profound and beautiful transformation occurs along the coastlines where ocean meets land. For billions of years, these boundaries have pulsed with the rhythm of tides, twice daily breathing of the sea that has shaped every aspect of marine life and coastal geography. Now, with the moon's gravitational influence removed from Earth's system, these ancient rhythms begin their gentle transition towards stillness, creating one of the most peaceful transformations our planet has ever experienced. Picture yourself standing on a familiar beach during these early months of change, watching as the tides gradually lose their urgency. The change doesn't happen overnight. The oceans are vast, and their momentum carries them forward for weeks after the moon's departure. But slowly, gradually, the twice-daily rush of water up and down the shore begins to diminish, like a great heartbeat slowly returning to rest after exertion. The sun still exerts its gravitational pull on Earth's waters, but this solar influence creates much gentler tides than the powerful lunar forces that previously dominated coastal rhythms. Where once the water might have risen and fallen by 10 or 15 feet twice each day, now the movement becomes a subtle whisper, perhaps only a foot or two of variation that takes longer to complete its cycle. The frantic energy of spring tides and the stillness of neap tides fade into memory, replaced by a more consistent, peaceful rhythm that seems to breathe with the longer cycles of Earth's relationship with the sun. Standing on your beach in the early morning hours, you can actually observe this transformation taking place. The waterline, which once moved with predictable urgency toward high tide mark and back again, now advances and retreats with a gentleness that seems almost meditative. The sound changes too. Instead of the powerful rush and retreat of substantial tidal movement, the waves create softer, more consistent music as they caress the shore with newfound tenderness. The tide pools that dot rocky coastlines begin their own transformation during this period. These small ecosystems, which evolved to survive the harsh cycle of submersion and exposure that tides created, now find themselves in a gentler world. The pools are still refreshed by wave action and the subtle solar tides, but the dramatic emptying and filling that characterized their existence for millions of years gradually gives way to more stable conditions. Remarkably, the creatures that live in these pools adapt with grace rather than struggle. Barnacles, mussels, and sea anemones that once spent their lives preparing for the next dramatic change in water level now exist in an environment of greater consistency. Marine biologists observing these changes note that many species seem to thrive in the more stable conditions, growing larger and reproducing more successfully without the constant stress of extreme tidal variation. The great salt marshes and estuaries where rivers meet the ocean undergo perhaps the most beautiful transformation of all. These ecosystems, which evolved as transitional zones between the rhythmic flooding of high tides and the exposure of low tides, gradually become more like peaceful lagoons. The salt marsh grasses, no longer subjected to twice daily flooding and draining, develop new growth patterns that create meadows of unusual lushness. Picture yourself walking through one of these transformed marshlands on a calm morning several months after the tides have stilled. Where once you would have needed to time your visit carefully to avoid being caught by rising water, you now find pathways that remain consistently passable. The channels that wind through the marsh still carry water, but they flow with the gentleness of meandering streams rather than the urgency of tidal currents. The bird populations that depend on these coastal environments adapt their feeding and nesting behaviors to the new rhythms. Shorebirds that once timed their migrations to coincide with optimal tidal conditions for feeding now discover that food sources are available more consistently. Many species extend their stays in particular areas, no longer driven to constant movement by the changing availability of feeding grounds that tidal rhythms once created. The great mudflats that were exposed during low tide begin their gradual colonization by plants and animals that previously could only survive in consistently dry or consistently wet conditions. These vast areas, now stable at a water level determined by the gentle solar tides and local drainage patterns, become new types of ecosystems unlike anything that existed when powerful lunar tides dominated coastal geography. Harbor towns and fishing communities face significant adjustments to these changing conditions, but the transformation occurs slowly enough that adaptation becomes a matter of gradual modification rather than sudden crisis. Fishing boats that once relied on high tide to lift them over harbor bars now find that water levels remain more consistent, though at heights that may be different from what they previously experienced. Many coastal communities discover that the gentling of tides brings unexpected benefits. Flooding that once threatened low-lying areas during extreme high tides becomes less of a concern, while harbors maintain more predictable water levels that actually simplify navigation and dock construction. The constant engineering battle against tidal forces that had challenged coastal development for centuries gradually eases, allowing for new approaches to waterfront architecture and marine infrastructure. The great tidal bore rivers, where incoming tides once created walls of water rushing upstream, transform into peacefully flowing waterways. The twice-daily reversal of flow that characterized these rivers gives way to more consistent downstream movement, allowing river ecosystems to develop new characteristics. Fish populations that once timed their movements to tidal flows adapt to the steadier currents, often expanding their ranges both upstream and downstream as the dramatic tidal barriers disappear. Marine mammals show fascinating adaptations to the changing coastal environment. Dolphins and whales that once used tidal currents to assist their movement through coastal waters develop new navigation patterns based on the steadier flow conditions. Many species actually seem to benefit from the more predictable water conditions, spending more time in coastal areas that were previously challenging to navigate due to rapidly changing tidal currents. The great kelp forests that thrive in many coastal regions experience their own transformation as the constant surge and retreat of tidal water gives way to gentler movements. These underwater cathedrals of marine vegetation adapt to the more stable conditions by growing denser and more extensive, creating habitat that supports larger and more diverse populations of marine life. The kelp, no longer stressed by extreme tidal movements, develops growth patterns that create even more beautiful and complex underwater landscapes. Seal and sea lion populations that once timed their breeding and hauling out behaviors to tidal schedules gradually adjust to the new coastal rhythms. Rocky coastlines that were previously accessible to these marine mammals only during certain tidal conditions now offer more consistent access, leading to new patterns of territory use and social behavior. Many colonies actually expand as previously marginal habitat becomes more consistently suitable for their needs. The transformation of estuarine environments where fresh and salt water meet creates some of the most beautiful changes in the coastal landscape. Without the twice-daily mixing action of strong tides, these areas develop more gradual gradients between fresh and salt water, creating new types of brackish environments. These transitional zones support different assemblages of plants and animals, often with greater diversity than the more dynamically changing conditions that existed under strong tidal influence. Coastal erosion patterns change dramatically as the constant grinding action of extreme tides diminishes. Cliffs and beaches that faced twice daily assault from tidal waters now experience gentler wave action, allowing vegetation to establish itself in areas that were previously too disturbed for plant growth. Many coastlines actually become more stable as the erosive power of extreme tides diminishes, though the reshaping continues at a much more gradual pace. The Great Barrier Islands and coastal sand formations begin to stabilize in new configurations as the powerful forces that constantly reshaped them diminish. These sandy environments, no longer subjected to the dramatic movement of sediment that strong tides created, develop more permanent features. Dunes stabilize and support more extensive vegetation, while channels between islands flow with gentler currents that support different types of marine life. Mangrove forests in tropical regions adapt to the more stable water levels by extending their range both seaward and landward into areas that were previously either too frequently submerged or too often exposed. These remarkable ecosystems, which evolved to thrive in the challenging interface between land and sea, now spread into more extensive coastal forests that provide habitat for even greater numbers of birds, fish, and other wildlife. The great coral reefs that fringe many tropical coastlines experience relief from the constant stress of extreme tidal exposure. Coral heads that once faced twice daily emergence during the lowest tides now remain consistently submerged, allowing them to grow larger and more elaborate. The reduced tidal flow also means less sedimentation and more stable conditions for the delicate symbiotic relationships that support coral ecosystem health. As the months continue to pass, coastal communities develop new traditions and activities around the changed character of their marine environment. Beach walking becomes a more contemplative activity without the urgency of timing visits to tidal schedules. Tidal pooling evolves into a more leisurely pursuit as the pools maintain more consistent conditions and can be visited at any time of day. The great rhythm that once defined coastal life, the ancient pulse of rise and fall that connected every shoreline to the cosmic dance of earth and moon, gradually fades into a gentler pattern that speaks more softly, but no less beautifully of our planet's relationship with the remaining celestial bodies that influence its motion. The sun continues to create its subtle tides, and local weather patterns still push water against the shore with varying intensity. But the fundamental character of the coast has shifted towards something more peaceful, more stable, and in many ways more welcoming to both human activity and natural diversity. This transformation of the coast represents one of the most visible signs that Earth has entered a new phase of its existence, where the rhythms that govern life are simpler but no less beautiful, where the interface between land and sea has become a place of greater peace and stability, supporting new forms of life and human activity that were impossible in the more dramatically changing world that existed when the moon's powerful influence shaped every coastline on the planet. Chapter 4: Earth's Gentle Wobble. As the first year passes in this moonless world, a transformation far more subtle but equally profound begins to manifest itself across the planet. Deep within Earth's core, the gyroscopic forces that have kept our planet spinning on a remarkably stable axis for billions of years start to shift in ways so gradual that no human lifetime could witness their completion, yet so fundamental that they will eventually reshape the very nature of seasons and climate across every continent. To understand this gentle transformation, picture Earth as a spinning top in the vast darkness of space. For as long as life has existed on our planet, the moon has served as a kind of cosmic anchor, its gravitational embrace keeping Earth's rotational axis steady at approximately 23.5 degrees of tilt. This tilt, stable and predictable, has created the familiar rhythm of seasons that has governed everything from migration patterns to agricultural cycles to the timing of holidays and festivals across every human culture. Now, with the moon's steadying influence removed, Earth begins what scientists call axial precession, a slow, graceful wobble that will unfold over thousands and tens of thousands of years. It's not a violent lurching or sudden change, but rather like watching a spinning coin gradually slow down and begin to wobble as it loses momentum. Except that Earth isn't losing momentum at all. It's simply no longer held steady by its former lunar companion. During these early years of the transformation, the changes are so subtle that they can only be detected by the most sensitive instruments. Astronomers notice that certain stars appear to shift their positions by tiny fractions of degrees over the course of months. The North Star, Polaris, which has served as humanity's celestial compass for millennia, begins an almost imperceptible drift away from true north. These changes occur so slowly that they're measured in arcseconds per year, movements so small that they're invisible to the naked eye and meaningless to daily life, yet significant enough to hint at the profound transformation that lies ahead. Picture yourself as an astronomer in one of the great observatories, spending night after night tracking these minute changes in stellar positions. Your measurements, accumulated over months and years, begin to reveal the pattern of Earth's new motion. The planet hasn't stopped spinning or changed the speed of its rotation significantly. It simply no longer maintains the steady orientation that the Moon once enforced. Instead, Earth's axis begins to trace a slow circle in space, like the handle of a spinning top that starts to wobble as it gradually tips and sways. This axial wobble will eventually cause dramatic changes in Earth's relationship with the Sun, but these transformations unfold over timescales that dwarf human history. In the immediate years following the Moon's departure, the effects are so gradual that seasonal patterns remain essentially unchanged. Spring still arrives when expected, summer heat still peaks at familiar times, autumn colors still paint the landscape in their traditional schedule, and winter cold still follows its ancient patterns. But sensitive observers begin to notice subtle differences. In the northern hemisphere, the summer solstice, that moment when the sun reaches its highest point in the sky, starts to occur at slightly different times relative to Earth's orbital position. The change amounts to just minutes per year, but astronomical instruments can detect the shift as Earth's wobbling axis gradually alters the timing of these celestial events. The effects are even more subtle in daily weather patterns. Climate scientists studying temperature and precipitation records notice tiny variations that don't quite match the familiar patterns of previous decades. These differences are so small that they fall within normal variations, but computer models that account for Earth's changing axial orientation begin to predict that more significant changes lie ahead as the wobble continues to develop over centuries and millennia. In the southern hemisphere, observers note similar minute changes in the timing of their seasons. The Southern Cross, that iconic constellation that has guided navigation in southern latitudes for centuries, begins an almost imperceptible drift in its nightly position relative to the horizon. Aboriginal astronomers, whose cultures have maintained detailed knowledge of stellar positions for thousands of years, are among the first to detect these changes, noticing that certain stars no longer rise at exactly the same positions on the horizon during traditionally significant times of year. The wobble affects different latitudes in different ways. Near the equator, where seasonal changes are normally minimal, the effects of axial precession are barely noticeable even over decades. But at higher latitudes, where the tilt of Earth's axis has a more dramatic effect on seasonal temperature and daylight patterns, the slow change in orientation begins to create subtle but measurable differences in the intensity and duration of seasons. Picture yourself living in northern Canada or Scandinavia during these early years of axial change. The midnight sun of summer and the polar night of winter still occur on schedule, but careful observers notice that the sun's path across the sky during these extreme seasons shifts slightly from year to year. The change is so gradual that it requires comparing detailed records over many years to detect, but it represents the beginning of a transformation that will eventually alter the entire character of polar seasons. This gradual wobble has fascinating effects on Earth's magnetic field as well. The planet's magnetism is generated by the motion of molten iron in the outer core, and this motion is influenced by Earth's rotation and orientation. As the axis begins its slow precession, the magnetic field starts to shift in response, though again so gradually that the changes are barely detectable even with sensitive instruments. The magnetic North Pole, which has always wandered slowly across the Arctic, begins to follow slightly different patterns as Earth's changing orientation influences the flow of molten metal deep beneath the surface. Migratory animals that navigate using magnetic cues show remarkable adaptability to these minute changes. Birds, sea turtles, and other creatures that depend on magnetic navigation continue their ancient journeys with little apparent difficulty, their internal compasses adjusting to the slowly changing magnetic environment. Their ability to adapt suggests that these species have encountered similar changes throughout their evolutionary history and possess the flexibility to maintain their navigation abilities even as the magnetic landscape gradually shifts around them. The space agencies of the world begin updating their calculations and orbital mechanics to account for Earth's changing orientation. Satellites that depend on precise positioning relative to Earth's axis require gradual adjustments to their operational parameters. The International Space Station and other orbital facilities adapt their navigation systems to account for the slowly shifting reference frame that Earth's wobble creates. Agricultural communities, whose planting and harvesting schedules have been refined over centuries to match local seasonal patterns, initially notice no significant changes in their traditional timing. The wobble's effects unfold too slowly to impact crop cycles in the near term, but agricultural scientists begin studying how the gradual changes in seasonal intensity might affect farming over the longer term. Computer models suggest that some regions might eventually experience slightly longer or shorter growing seasons as Earth's wobble alters the angle at which sunlight strikes different latitudes. Ocean currents, those great rivers of warm and cold water that moderate Earth's climate, begin subtle adjustments to the changing patterns of solar heating that result from the planet's wobbling axis. The Gulf Stream, the Kuroshio Current, and other major oceanic flows continue their ancient circulation patterns, but sophisticated monitoring equipment detects minute changes in temperature and flow that reflect the gradually shifting seasonal patterns that drive these currents. Weather prediction models incorporate the new variables that Earth's axial precession introduces, though the changes are so gradual that they have minimal impact on short-term forecasting. Long-term climate models, however, begin to show how the wobble will eventually lead to more significant changes in regional climate patterns as the altered relationship between Earth's axis and its orbit around the Sun gradually shifts the distribution of solar energy across the planet's surface. Indigenous cultures around the world, many of which maintain detailed oral traditions about astronomical observations, begin updating their traditional knowledge to account for the slowly changing sky. Elders who have spent lifetimes learning the precise timing of stellar events start to notice discrepancies between traditional teachings and current observations, leading to new chapters in cultural knowledge that acknowledge the changed relationship between Earth and the cosmic environment. Architects and urban planners begin considering the long-term implications of Earth's changing orientation. Buildings designed to take advantage of specific solar angles for heating and lighting may need different orientations in the distant future, though the changes will unfold so slowly that most structures will be rebuilt many times before the shift becomes significant enough to affect their design. The wobble creates new opportunities for astronomical research as Earth's changing orientation gradually provides different perspectives on the universe. Over thousands of years, the slow precession will eventually point Earth's axis toward different stars, giving future astronomers new pole stars and altered views of the cosmic environment. This gradual change in perspective will reveal stellar phenomena that are currently hidden by Earth's orientation and provide opportunities for discoveries that would be impossible with a stable axis. Scientists studying Earth's rotation detect minute changes in the length of days as the planet's wobble begins to affect its spin. These changes amount to microseconds per year. Differences so small that they have no practical impact on daily life, but significant enough to require adjustments in the atomic clocks that maintain global time standards. The wobble introduces tiny variations in rotational speed that create a new kind of temporal complexity in Earth's relationship with cosmic time. As years turn into decades in this slowly wobbling world, the changes remain subtle enough that most people live their entire lives without consciously noticing the transformation. But the accumulated effect of these minute-annual changes begins to create a planet that is gradually, almost imperceptibly, different from the stable, moon-anchored world that humanity has always known. Earth has begun a new kind of cosmic dance, one that unfolds over geological timescales and will eventually lead to seasonal patterns and climate characteristics unlike anything in recorded history. This gentle wobble represents one of the most profound, but least immediately obvious consequences of the moon's departure. A reminder that even the most subtle changes in cosmic relationships can have far-reaching effects that unfold across timescales that challenge human comprehension while demonstrating the remarkable interconnectedness of planetary systems and the delicate balance of forces that shape the environment of our world. Chapter 5. The Lengthening Days. As Earth settles into its second year without the moon's gravitational partnership, another subtle but profound transformation begins to manifest itself in the rhythm of daily life. For billions of years, the moon's gravitational pull has not only created the tides, but also acted as a gentle brake on Earth's rotation, gradually slowing our planet's spin through what scientists call tidal friction. With this braking force suddenly removed, Earth's rotation begins a slow but inexorable acceleration that will eventually reshape the very nature of day and night. The change is so gradual at first that it can only be detected by atomic clocks and sophisticated astronomical instruments. In the months immediately following the moon's departure, Earth's rotation gains mere milliseconds per year, a difference so tiny that it would take sensitive equipment running continuously for months to detect the shift. But this acceleration, small as it may seem, represents the beginning of a transformation that will fundamentally alter the rhythm of life on our planet. Picture yourself as a chronometer specialist at one of the world's timekeeping institutions, monitoring the relationship between Earth's rotation and the atomic clocks that define our measurement of time. Week by week, month by month, you begin to notice that Earth is spinning just slightly faster than your calculations predict. The difference is measured in fractions of seconds per year, but the trend is unmistakable. Our planet is gradually speeding up its rotation now that the moon's gravitational drag is no longer slowing it down. This acceleration affects the length of each day, though the changes unfold so slowly that they remain invisible to ordinary experience for decades. In the early years after the moon's departure, a day might be shortened by only microseconds annually, a difference that has no practical impact on human activities but represents a measurable change in Earth's fundamental rhythm. Over the span of a human lifetime, these tiny increments will accumulate into changes that become noticeable, and over geological timescales, they will transform the nature of day and night entirely. The process creates fascinating complexities for systems that depend on precise time measurement. GPS satellites, which require extraordinarily accurate timing to provide location services, need gradual adjustments to account for Earth's changing rotational period. The atomic clocks that synchronize global communications and financial transactions begin to show minute discrepancies with astronomical time as Earth's spin gradually accelerates beyond the rates that these systems were designed to accommodate. As the years pass, the effects begin to manifest in ways that careful observers can detect. Astronomers tracking the positions of stars notice that celestial objects appear to move slightly faster across the sky from night to night. The change is subtle, perhaps a few arc-seconds per year in the apparent motion of stars relative to Earth's surface, but it represents a real shift in the planet's relationship with the cosmic environment surrounding it. Picture yourself as an amateur astronomer who has spent years photographing the same section of sky at the same time each night. After several years of accumulating images, you begin to notice that the star trails, those streaks of light that stars create during long exposures, are becoming slightly shorter. The stars haven't changed their motion through space, but But Earth's faster rotation means that each exposure captures a slightly smaller arc of the sky's apparent movement. The changing day length begins to affect biological rhythms in ways that are initially too subtle to notice, but gradually become more apparent. Many organisms have internal clocks that are synchronized to the 24-hour day-night cycle, and these biological rhythms begin to show tiny discrepancies as Earth's rotation accelerates. Plants that time their flowering or leaf movements to specific hours of the day start to show minute shifts in their schedules as the length of daylight and darkness periods gradually changes. Researchers studying circadian rhythms in humans and animals begin to detect subtle variations in sleep-wake cycles and other biological processes. The changes are so gradual that they fall within normal variations for many years. But long-term studies reveal patterns that suggest biological systems are slowly adapting to the changing rhythm of day and night. Some individuals seem to be more sensitive to these minute changes than others, developing sleep patterns that shift gradually ahead of the traditional 24-hour cycle. The acceleration has particularly interesting effects on weather patterns and atmospheric circulation. The rotation of the Earth drives the Coriolis effect, which influences everything from the direction of wind patterns to the circulation of ocean currents. As the planet spins faster, these effects intensify slightly, creating minute changes in global circulation patterns that are barely detectable in the short term, but may have more significant impacts as the acceleration continues over decades and centuries. Meteorologists studying long-term weather data begin to notice tiny variations in storm patterns and seasonal wind behaviors. Hurricane formation and tracking shows subtle differences as the changing Coriolis forces affect the way these massive weather systems develop and move. The changes are so small that they remain within normal variation ranges for individual storms. But statistical analysis of hundreds of weather events begins to reveal the fingerprint of Earth's changing rotation. Picture yourself living in a coastal city during these early years of rotational acceleration, observing weather patterns that seem almost imperceptibly different from those of previous decades. Storm systems might track slightly differently, or seasonal wind patterns might shift by small amounts that are noticeable only when compared to detailed records from years past. The changes don't create dramatic differences in daily weather, but they represent the beginning of a new relationship between Earth's rotation and the atmospheric dynamics that create climate. The acceleration affects the planet's shape in minute ways as well. Earth is not a perfect sphere, but rather an oblate spheroid, slightly flattened at the poles and bulged at the equator due to the centrifugal force of rotation. As the planet spins faster, this bulge increases almost imperceptibly, causing subtle changes in the distribution of mass that can be detected by gravitational measurements and satellite observations. These tiny changes in Earth's shape have cascading effects on everything from satellite orbits to the precise measurement of distances on the Earth's surface. GPS coordinates that were once accurate to within centimeters begin to show minute drifts as the changing shape of the planet alters the relationship between surface positions and the satellite constellation that provides positioning data. The effects are so small that they require correction only in the most precise scientific applications, but they represent real changes in the fundamental geometry of our world. Ocean currents begin to show subtle responses to the changing rotational speed as well. The great circular currents that transport heat around the globe are driven partly by the Coriolis effect, and the slight strengthening of this force as Earth spins faster creates minute changes in circulation patterns. Deep ocean monitoring stations detect tiny variations in current speed and direction that reflect the planet's changing dynamics. The faster rotation has interesting effects on the behavior of Earth's atmosphere at high altitudes. The upper atmosphere, which rotates with the planet, experiences slightly increased centrifugal forces that cause minute changes in density and circulation patterns. These effects are most noticeable at the poles, where the changing rotational dynamics create subtle variations in the aurora displays as charged particles from the sun interact with the slightly altered magnetic field configurations that result from the faster spin. Picture yourself as a researcher studying atmospheric physics during these years of gradual change. Your instruments detect tiny variations in air pressure and wind patterns at high altitudes that seem to correlate with the planet's changing rotation rate. The effects are so subtle that they require years of data collection to establish clear patterns, but they represent genuine changes in how Earth's atmosphere responds to the cosmic environment. The acceleration affect precision industries that depend on exact timing in unexpected ways. Manufacturing processes that require synchronization to fractions of seconds begin to show minute timing errors that accumulate over weeks and months. Computer networks that depend on precise time synchronization need gradual adjustments to account for the changing relationship between atomic time and astronomical time as Earth's rotation gradually diverges from the rates that these systems were designed to accommodate. Radio astronomy facilities that track celestial objects notice that their automated tracking systems require slight recalibration as Earth's faster rotation changes the apparent motion of radio sources across the sky. The changes are tiny, perhaps requiring adjustment of a fraction of a degree per year in tracking calculations, but they represent real shifts in our planet's relationship with the cosmic radio environment. The changing day length begins to affect tidal calculations in subtle ways as well. Although the moon is no longer present to create strong tides, the sun continues to exert gravitational influence on Earth's oceans, and the timing of these solar tides shifts minutely as the planet's rotation accelerates. Coastal monitoring stations detect tiny changes in the timing of high and low water that reflect Earth's changing rotational period. Agricultural communities that have refined their planting and harvesting schedules over centuries to match precise daylight hours begin to notice minute discrepancies between traditional timing and optimal conditions. The changes are so gradual that they have no immediate practical impact. But agricultural scientists studying crop responses to daylight duration detect subtle variations that suggest plants are beginning to respond to this slowly changing day-night cycle. As the acceleration continues over years and decades, these minute changes begin to accumulate into differences that become noticeable to careful observers. Stargazers who have spent years learning the precise timing of celestial events start to detect small discrepancies between traditional astronomical calculations and observed phenomena. The changes require updating of astronomical tables and navigation systems that have been based on Earth's previous moon-stabilized rotation rate. The gradual shortening of days represents one of the most fundamental but least immediately obvious changes in this moonless world. While the effects remain subtle for human timescales, they demonstrate how the removal of the moon's influence allows Earth to return to rotational behaviors that were suppressed for billions of years by lunar tidal friction. Our planet is slowly remembering how to spin without the gentle braking effect that the moon provided, beginning a process that will eventually create a world where days are significantly shorter and the rhythm of life moves to a faster cosmic beat. This acceleration serves as a reminder of how intimately connected Earth's basic properties are to its relationship with other celestial bodies, and how even subtle changes in these cosmic partnerships can have far-reaching effects that unfold across timescales, ranging from immediate instrumental measurements to geological transformations that will reshape the fundamental rhythm of existence on our planet. Chapter 6: Seasons in Slow Motion. As Earth continues its gentle wobble through the third and fourth years without the moon, the combined effects of axial precession and changing rotational dynamics begin to create subtle but increasingly noticeable variations in the character of seasons themselves. The changes unfold so gradually that they might be mistaken for normal climate variation. But careful observers start to detect patterns that suggest something fundamental is shifting in the way our planet experiences its annual journey around the sun. Picture yourself as a phenologist, someone who studies the timing of natural seasonal events, returning to the same woodland each spring to document when specific flowers bloom, when particular birds arrive from their winter migrations, and when trees burst into their full leafy glory. For the first few years after the moon's departure, your observations remain largely consistent with decades of previous records. The bloodroot still emerges through the snow at nearly the same date. the wood warblers still return within a few days of their traditional arrival time, and the oak trees still unfurl their leaves according to ancient schedules. But as you accumulate several years of data in this moonless world, subtle patterns begin to emerge. Some springs seem to arrive a day or two earlier than your historical averages would predict, while others appear slightly delayed. The variations fall within normal ranges for individual years, but when analyzed collectively, they reveal a slow drift away from the stable seasonal timing that characterized the moon-stabilized Earth. The wobble in Earth's axis creates these variations by slightly altering the angle at which sunlight strikes different regions during different parts of the year. In some years, the precession causes the northern hemisphere to be tilted slightly more toward the sun during spring, creating earlier warming and advanced seasonal development. In other years, the wobble tilts the same regions slightly away from optimal solar angles, delaying the onset of spring conditions by small but measurable amounts. These changes are most noticeable at higher latitudes, where seasonal variations are naturally more extreme. In northern Canada, Scandinavia, and Siberia, indigenous peoples whose cultures have maintained detailed observations of seasonal timing for generations begin to notice discrepancies between traditional knowledge and current conditions. Elders who learn to predict ice breakup, migration timing, and optimal hunting seasons from their ancestors find that the old patterns no longer match perfectly with observed conditions. Picture yourself spending time with Inuit communities in the Canadian Arctic during these years of transition. The elders share stories of how their grandparents predicted the arrival of specific animals or the timing of ice formation based on observations of stars, wind patterns, and other natural signs. While these traditional predictions still work remarkably well, small discrepancies begin to appear. Perhaps the caribou migration begins a few days later than the old stories suggest, or the formation of safe sea ice occurs slightly ahead of traditional timing. The variations affect plant communities in fascinating ways. Deciduous forests that have evolved to coordinate their leaf emergence with specific temperature and daylight conditions begin to show increased variation in their timing from year to year. Some springs, when Earth's wobble creates favorable solar angles, produce spectacular early blooms that create unusual overlaps between species that normally flower in sequence. Other years bring delayed spring conditions that compress the flowering season into a shorter period later in the year. Agricultural communities start to notice these seasonal variations in their crop planning and harvesting schedules. Farmers who have refined their planting dates over decades to optimize growing seasons find that the traditional timing sometimes works perfectly, while in other years, slightly earlier or later planting would have been optimal. The variations aren't dramatic enough to cause crop failures, but they represent a new kind of uncertainty in agricultural planning that previous generations never experienced. Picture yourself as a farmer in the American Midwest during this period of seasonal transition. Your family has farmed the same land for generations, passing down knowledge about optimal planting dates for corn and soybeans, when to expect the last frost of spring, and how to time harvest to avoid autumn weather problems. While this traditional knowledge still serves you well most years, you begin to notice seasons that don't quite match the patterns you learned from your parents and grandparents. The changing seasonal patterns affect wildlife migration routes and timing in subtle but important ways. Birds that navigate using both magnetic cues and stellar positions find that their traditional timing sometimes brings them to breeding grounds before optimal conditions have developed, or after peak resource availability is passed. Many species demonstrate remarkable adaptability, adjusting their migration schedules based on environmental cues they encounter during their journeys rather than relying solely on internal timing mechanisms. Waterfowl migration becomes particularly interesting to observe during these years of seasonal variation. Ducks, geese, and swans that have followed the same flyways for thousands of years begin to show more flexibility in their timing, with some populations arriving at traditional stopover sites earlier or later than historical norms would predict. Wildlife biologists studying these patterns note that the birds seem to adapt their schedules based on actual conditions they encounter rather than strict adherence to traditional timing. The seasonal variations affect flowering plants and their pollinators in complex ways that create both challenges and opportunities for ecosystem relationships. In years when Earth's wobble advances the spring season, early flowering plants may bloom before their primary pollinators have emerged from winter dormancy. Conversely, when seasonal development is delayed, some flowers might miss optimal pollination periods as insects emerge according to temperature cues that no longer match flowering timing. Picture yourself as a beekeeper managing hives through these years of seasonal uncertainty. Your experience teaches you to expect certain plants to bloom in specific sequences that provide continuous nectar sources for your colonies throughout the growing season. While this succession still generally holds true, you notice years when gaps appear in the flowering schedule, or when multiple species bloom simultaneously instead of in their traditional sequence, requiring adjustments to hive management and honey production planning. The gradually shifting seasonal patterns begin to affect the timing of autumn colors and leaf fall in deciduous forests. Trees that have evolved to time their dormancy preparation based on daylight length and temperature patterns occasionally find themselves responding to environmental cues that no longer align perfectly with optimal timing for winter survival. Some autumns bring earlier color changes and leaf drop, while others extend the growing season beyond traditional dates. These variations in autumn timing create spectacular but unpredictable displays of fall colors. In years when the seasonal timing aligns favorably, forests produce particularly vibrant and long-lasting color displays as trees have more time to complete their autumn preparation. Other years bring compressed autumn seasons where color changes happen more rapidly, creating intense but brief periods of peak foliage that differ from traditional expectations. Winemaking regions begin to experience variations in grape ripening that reflect the subtle changes in seasonal development. Vintners who have refined their harvest timing over decades to optimize sugar and acid levels in their grapes find that traditional harvest dates sometimes produce perfect results, while in other years, slightly earlier or later harvesting would be optimal. These variations add new complexity to wine production, but also create opportunities for unique vintages that reflect the changing seasonal patterns. Picture yourself visiting wine country during these years of seasonal transition, talking with vintners who are adapting their practices to account for less predictable seasonal timing. While the variations aren't dramatic enough to threaten wine production, they require more flexibility in harvest planning and create new challenges for maintaining consistent wine quality from year to year. The changing seasonal patterns affect cold weather sports and recreation in interesting ways. Ski resorts and winter recreation areas find that snow accumulation and melting patterns show more year-to-year variation than historical norms would predict. Some winters bring earlier snowfall and extended seasons, while others feature delayed snow accumulation or early melting that shortens the traditional winter sports season. Ice fishing communities in northern regions adapt to variations in ice formation timing that reflect the subtle changes in winter development. Lakes and rivers that traditionally froze solid by specific dates show more variability in ice formation, requiring ice fishers to be more flexible in their seasonal planning and more careful in assessing ice safety conditions. The seasonal variations begin to influence the behavior of hibernating animals as they respond to environmental cues that no longer follow perfectly predictable patterns. Bears, ground squirrels, and other hibernating species show more flexibility in their timing for entering and emerging from dormancy, basing their decisions on actual temperature and food availability conditions rather than strict adherence to traditional seasonal timing. Picture yourself as a wildlife researcher studying hibernation patterns during these years of seasonal transition. Your data shows that animals are demonstrating remarkable adaptability to the changing seasonal cues, often emerging from hibernation when conditions are actually optimal rather than on traditional calendar dates. This flexibility suggests that many species possess adaptive mechanisms that allow them to thrive despite subtle changes in seasonal timing. Gardeners and horticulturists begin to adjust their practices to account for the increased variability in seasonal development. Traditional gardening calendars that specified optimal times for planting, pruning, and harvesting become guidelines rather than strict schedules, as gardeners learn to respond to actual growing conditions rather than calendar dates. The seasonal variations affect the production cycles of maple syrup and other seasonal agricultural products that depend on specific weather patterns. Maple syrup producers find that the sap runs that traditionally occurred during predictable temperature cycles now show more variation in timing and intensity, requiring more flexible approaches to syrup production planning. As these seasonal variations continue to develop over years and decades, they create a world where natural timing becomes less predictable but more responsive to actual conditions. The stable seasonal patterns that characterized Earth under the moon's stabilizing influence give way to a more dynamic relationship between planetary position and seasonal development, creating new challenges and opportunities for all forms of life that depend on seasonal timing for their survival and reproduction. This gradual shift toward more variable seasonal patterns represents another fundamental change in how Earth operates without the moon's stabilizing influence, demonstrating how even subtle alterations in planetary dynamics can cascade through natural systems in ways that affect everything from individual plant flowering to global patterns of wildlife behavior and agricultural production. Chapter 7. Life Adapts in Harmony. As the 5th and 6th years unfold in this moonless world, the accumulated effects of all these gentle transformations begin to manifest in the remarkable ways that life itself responds to the changed conditions on Earth. The deeper darkness, the stilling of tides, the subtle wobble of the planet's axis, the gradually shortening days, and increasing variability in seasonal timing have created a new environmental context that living organisms across the planet are adapting to with the extraordinary resilience that has allowed life to thrive through countless changes throughout Earth's long history. Picture yourself as a field biologist returning to study sites you've monitored for decades, armed with detailed records of how species behaved and ecosystems functioned in the moon-dominated world. As you begin your observations in this transformed environment, you discover that adaptation is happening not through struggle and crisis, but through gradual adjustments that often enhance rather than diminish the beauty and complexity of natural communities. In the coastal regions where tides have gentled into barely perceptible rhythms, marine ecosystems have reorganized themselves in ways that create new forms of abundance and diversity. The intertidal zones, once harshly divided between organisms that could tolerate regular exposure and those that required constant submersion, have become transition areas where marine and terrestrial life intermingle in novel ways. Seaweeds that once grew only in the low tide zone now extend their range into areas that were previously too often exposed, creating underwater meadows of unusual richness. The marine animals that once timed their reproduction to tidal cycles have discovered new rhythms based on lunar-free environmental cues. Fiddler crabs, whose mating displays once synchronized precisely with tidal schedules, now respond to subtle temperature variations and the availability of food sources that flow with weather patterns rather than twice-daily tidal movements. Their populations have actually increased in many areas, as the more stable water levels provide consistent habitat that was previously available only during certain tidal phases. Picture yourself wading through a transformed tide pool during these years of adaptation, observing communities of sea anemones, barnacles, and small fish that have established themselves in pools that now maintain more consistent water levels. The constant stress of tidal exposure and submersion has been replaced by gentler variations that allow these communities to develop greater complexity and stability. Many species grow larger than they could when subjected to the harsh cycle of tidal extremes, creating underwater gardens of unusual beauty and diversity. The fish populations in coastal waters show fascinating adaptations to the changed tidal environment. Species that once used tidal currents for feeding and navigation have developed new behaviors based on weather-driven water movements and the subtle solar tides that still influence coastal waters. Many coastal fish populations have expanded their ranges as previously challenging tidal barriers have disappeared, allowing species to explore habitat that was formerly inaccessible during certain tidal phases. In the terrestrial ecosystems, the profound darkness of moonless nights has created conditions that allow nocturnal communities to flourish in ways that were impossible when moonlight illuminated their activities. Predator-prey relationships have shifted toward more complex interactions that depend on sound, scent, and other non-visual cues, creating ecosystems where cooperation and camouflage often prove more successful than aggressive competition. Picture yourself sitting quietly in a forest clearing during one of these dark, moonless nights, listening to the sounds of a nocturnal community that has adapted to navigate by hearing and scent rather than sight. Owls have developed even more sophisticated hunting techniques that rely entirely on their extraordinary hearing abilities, while their prey species have evolved enhanced awareness of sound and vibration that helps them avoid detection. The absence of moonlight has actually created more opportunities for successful hunting and foraging, as both predators and prey operate under equally challenging visual conditions. The plants of this moonless world have adapted to the changed light conditions by developing enhanced sensitivity to starlight and the subtle variations in darkness that occur throughout the night. Many night-blooming flowers have evolved to open during the deepest darkness hours, taking advantage of the absence of moonlight to attract pollinators through enhanced fragrances rather than visual displays. These adaptations have created gardens that engage the sense of smell more intensely than ever before, with evening air filled with complex bouquets of floral scents that guide nocturnal pollinators to their targets. Nocturnal pollinators, including moths and night-flying beetles, have developed more sophisticated navigation abilities that allow them to locate flowers using scent trails and the subtle visual cues provided by starlight. Many species have actually expanded their foraging ranges in the deeper darkness, as they can move more freely without the exposure that moonlight previously created. The result is more effective pollination networks that connect plant communities across larger distances than was possible in the moonlit world. The absence of lunar cycles has freed many organisms from the rigid timing constraints that once governed their reproductive and feeding behaviors. Animals that once synchronized their mating activities with moon phases now respond to a broader range of environmental cues, often with greater flexibility that allows them to take advantage of optimal conditions whenever they occur rather than waiting for specific lunar timing. Picture yourself observing a coral reef during these years of adaptation, where corals that once released their reproductive materials in strict accordance with lunar cycles now spawn in response to water temperature, seasonal changes, and local environmental conditions. This increased flexibility has actually improved reproductive success for many species, as they can respond to optimal conditions rather than being constrained by lunar timing that might not coincide with favorable environmental circumstances. The bird communities of this moonless world have developed remarkable adaptations to the changed light conditions and the absence of lunar navigation cues. Migrating species have become more reliant on stellar navigation and magnetic field detection, often with greater accuracy than they achieved when moonlight sometimes interfered with their ability to detect subtle magnetic variations. Many migratory routes have actually become more direct and efficient as birds learn to navigate using the enhanced star visibility that the dark nights provide. Night-singing birds have expanded their vocal repertoires and extended their active periods to take advantage of the profound quiet that comes with the deeper darkness. Without moonlight to reveal their positions to predators, many species can sing more freely and for longer periods, creating dawn and dusk choruses of unprecedented richness and complexity. The soundscape of the moonless world has become more varied and beautiful as birds explore new vocal territories that were too risky when moonlight made them visible to predators. The terrestrial mammals of this transformed world have adapted to the darker nights by developing enhanced senses and more sophisticated social behaviors. Pack hunters like wolves have refined their cooperative strategies to work effectively in the deeper darkness, often with improved success rates as their prey animals face the same visual limitations. Many mammal species have actually expanded their ranges and population sizes as the darker nights provide better cover for movement and foraging activities. Picture yourself tracking a family of foxes during these moonless nights, observing how they've adapted their hunting strategies to rely more heavily on their extraordinary hearing and scent detection abilities. Their success rates have often improved in the darker environment, as they possess sensory advantages that many of their prey species cannot match. The deeper darkness has created new ecological niches that these adaptable predators have learned to exploit with remarkable efficiency. The insect communities have undergone some of the most spectacular adaptations to the moonless environment. Fireflies, freed from competition with moonlight, have developed more elaborate and extensive mating displays that illuminate summer evenings with unprecedented beauty. Their synchronous flashing patterns have become more complex and widespread, creating natural light shows that rival any fireworks display and serve as one of the most visible signs that life has not only adapted to the moonless world, but found ways to make it more beautiful. Night-flying moths and other nocturnal insects have adapted to navigate using star patterns rather than lunar cues, often with improved directional accuracy. Many species have extended their flight periods and expanded their ranges as the darker nights provide better protection from visual predators. The result is more diverse and active nocturnal insect communities that support enhanced populations of bats, spiders, and other creatures that depend on insect populations for food. The plant communities have shown remarkable plasticity in adapting to the changed growing conditions created by the planet's gradual axial wobble and the subtle variations in seasonal timing. Many species have developed broader tolerance ranges for temperature and light conditions, allowing them to thrive despite the increased variability in seasonal development. This flexibility has actually increased plant diversity in many ecosystems, as species that were previously limited by narrow environmental requirements can now exploit a wider range of conditions. Picture yourself walking through a meadow during these years of adaptation, observing wildflowers that have learned to respond to actual growing conditions rather than rigid seasonal timing. Some species bloom multiple times per season when conditions are favorable, while others have developed extended flowering periods that take advantage of the more variable seasonal patterns. The result is often more colorful and diverse displays that last longer than the traditional flowering seasons of the moon-stabilized world. Forest ecosystems have adapted to the changing seasonal patterns by developing more flexible responses to environmental cues. Trees that once relied on strict photoperiod responses now integrate multiple environmental signals to time their leaf emergence, flowering, and dormancy preparation. This increased responsiveness has actually improved forest health in many areas, as trees can respond to favorable conditions whenever they occur rather than being constrained by rigid seasonal timing. The soil communities that support all terrestrial life have also adapted to the changed conditions with remarkable resilience. Earthworms, soil bacteria, fungi, and countless microscopic organisms have adjusted their activities to the new patterns of temperature, moisture, and organic matter availability that result from the changed seasonal timing and the absence of lunar influences on biological rhythms. Many soil ecosystems have actually become more productive as the increased environmental variability creates diverse microhabitats that support greater biological diversity. Aquatic ecosystems in lakes and rivers have benefited from the absence of tidal influences and the changed seasonal patterns in ways that often enhance rather than diminish their biological productivity. Fish populations that were once constrained by predictable seasonal patterns now respond more flexibly to environmental conditions, often with improved reproductive success and expanded population ranges. Many freshwater communities have become more diverse and stable as they adapt to environmental cues that reflect actual local conditions rather than distant cosmic influences. Picture yourself studying a mountain lake during these years of adaptation, observing fish communities that have learned to spawn in response to optimal water temperature and food availability rather than rigid seasonal timing. The flexibility has often improved reproductive success and allowed populations to take advantage of favorable conditions whenever they occur throughout the extended growing seasons that the changed axial wobble sometimes creates. As these adaptations continue to unfold across the biological communities of Earth, a pattern emerges that speaks to the remarkable resilience and creativity of life itself. Rather than struggling against the changed conditions, most organisms have found ways to thrive in the new environment, often discovering opportunities for enhanced survival and reproduction that were impossible in the more rigidly structured world that existed under lunar influence. The moonless Earth has become not a diminished world, but a different one, where life has learned to dance to new cosmic rhythms while maintaining the essential beauty and complexity that makes our planet a celebration of biological creativity and adaptation. Chapter 8: The Ocean's New Song. As Earth completes nearly a decade without its lunar companion, perhaps nowhere are the transformations more profound or beautiful than in the vast oceanic systems that cover more than 70% of our planet's surface. The oceans, which for billions of years pulsed with the rhythm of lunar tides, have now settled into entirely new patterns of circulation, life, and beauty that demonstrate nature's extraordinary capacity to create harmony from change. Picture yourself standing on a cliff overlooking the Pacific Ocean during these years of transformation, watching waters that move with rhythms unlike anything in human memory. The twice-daily breathing of the sea that once defined coastal life has given way to movements that follow different laws. The gentle solar tides that create barely perceptible rises and falls, the weather-driven surges that respond to distant storms, and the great currents that continue their ancient circulation but now flow through a world where coastal boundaries have stabilized in new configurations. The absence of strong tidal forces has allowed the ocean to reveal characteristics that were previously masked by the constant movement of lunar-driven waters. Nearshore areas that once experienced dramatic changes between high and low tide have become more like vast lagoons, their waters clear and stable in ways that create unprecedented opportunities for marine life to flourish. These coastal zones, no longer subjected to the twice-daily stress of extreme water level changes, have developed into some of the most diverse and productive marine ecosystems on the planet. Swimming in these transformed coastal waters feels like entering a different ocean entirely. The water clarity that develops in the absence of tidal stirring allows sunlight to penetrate deeper than before, creating underwater landscapes of extraordinary beauty where coral reefs and kelp forests extend into waters that were previously too turbulent to support such delicate communities. The gentle movement of water driven by weather patterns and the subtle solar tides creates currents that are more predictable and less violent than the powerful tidal flows that once dominated nearshore environments. Picture yourself snorkeling in one of these transformed coastal areas, perhaps off the coast of California, where kelp forests have expanded into waters that were previously too disturbed by tidal action to support their growth. The underwater cathedral of giant kelp now extends and unbroken stands for miles along the coast, creating habitat for marine communities of unprecedented diversity and abundance. Fish populations that were once fragmented by tidal barriers now move freely through continuous underwater forests, creating opportunities for species interactions and ecosystem development that were impossible in the tidally dominated world. The great kelp forests have become living laboratories for observing how marine ecosystems adapt to changed conditions. Without the constant pruning action of extreme tidal flows, kelp can grow larger and live longer, creating underwater forests of cathedral-like grandeur, where the interplay of sunlight and shadow through the swaying fronds creates an ever-changing display of underwater beauty. These expanded kelp ecosystems support larger populations of sea otters, seals, and countless fish species that depend on the forest structure for feeding and protection. The coral reefs of tropical oceans have experienced their own remarkable transformation in the absence of tidal stress. Reef systems that were once limited to specific depth ranges by tidal exposure can now extend both deeper and into shallower waters, creating continuous reef communities that stretch for unprecedented distances along tropical coastlines. The corals themselves, no longer subjected to the stress of regular exposure during extreme low tides, have grown larger and developed more complex structures that support greater biodiversity than was possible under tidal conditions. Picture yourself diving along the Great Barrier Reef during these years of transformation, observing coral communities that have expanded into previously marginal areas and developed new growth forms that take advantage of the more stable water conditions. Brain corals grow larger and more elaborate. Staghorn corals develop more intricate branching patterns, and soft corals create underwater gardens of unprecedented beauty and complexity. The fish communities that depend on these reefs have responded to the expanded habitat with population increases and range extensions that have made these underwater ecosystems more vibrant and diverse than ever before. The deep ocean currents that drive global climate patterns have also adapted to the absence of tidal mixing, developing new characteristics that often improve their efficiency at distributing heat and nutrients around the planet. The Gulf Stream, the Kuroshio Current, and other major oceanic rivers continue their ancient circulation patterns, but now flow through waters that are less disturbed by tidal turbulence, allowing them to maintain more consistent temperatures and carry larger volumes of water with greater efficiency. Oceanographers studying these transformed currents discover that the absence of tidal interference actually strengthens many major circulation patterns, creating more stable and predictable ocean currents that enhance rather than diminish their role in moderating global climate. The thermohaline circulation that carries warm water toward the poles and cold water toward the equator operates more smoothly without the constant disruption of tidal mixing, creating ocean currents that are more efficient at distributing heat around the planet. Picture yourself aboard a research vessel studying the transformed North Atlantic circulation during these years of change, using sophisticated instruments to map current patterns that show remarkable stability and strength compared to pre-transformation measurements. The warm waters of the Gulf Stream flow with unusual consistency toward Europe, while the cold Labrador current maintains steady flow patterns that create more predictable climate conditions for the regions they influence. The marine life that depends on these major currents has adapted to their enhanced stability with remarkable success. Migrating species like whales, sea turtles, and large fish find that ocean currents now provide more reliable transportation routes, often allowing them to complete their journeys with greater efficiency and predictability than was possible when tidal effects created constant variations in current strength and direction. Following a pod of humpback whales during their annual migration reveals how these intelligent marine mammals have adapted their travel routes to take advantage of the more stable current patterns. The whales can now predict with greater accuracy where they will find the strongest currents to assist their journey, and they often complete their migrations faster and with less energy expenditure than before the transformation. Their songs, which carry for hundreds of miles through ocean water, now travel through underwater environments that are acoustically clearer due to reduced tidal turbulence. The deep ocean environments, far from the influence of surface conditions, have also been transformed by the absence of tidal forces. The mixing of ocean layers that tides once created has been replaced by gentler vertical circulation patterns driven by temperature and salinity differences. This change has actually improved the distribution of nutrients throughout the water column in many areas, creating conditions that support enhanced productivity in both surface and deep water ecosystems. Picture yourself in a deep-sea submersible exploring the abyssal plains during these years of transformation, observing communities of deep-sea creatures that have benefited from the improved nutrient distribution and the absence of tidal disturbance. The deep-sea coral gardens that grow in the eternal darkness of the ocean depths have expanded their ranges and developed more complex structures in the more stable water conditions. Bizarre fish, giant tube worms, and countless other deep-sea organisms have established communities of greater density and diversity than existed under tidal influence. The hydrothermal vents that create oases of life in the deep ocean have also been affected by the changed circulation patterns. The mineral-rich water that flows from these underwater volcanoes now disperses in more predictable patterns, creating larger and more stable ecosystems around vent communities. The unique organisms that depend on chemosynthesis rather than photosynthesis for energy have expanded their populations and developed new symbiotic relationships that create deep-sea communities of unprecedented complexity and beauty. Ocean productivity has actually increased in many regions due to the more efficient circulation patterns and improved nutrient distribution that characterize the transformed marine environment. Phytoplankton, the microscopic plants that form the base of most marine food webs, often achieve higher population densities in the more stable water conditions. These enhanced phytoplankton populations support larger numbers of zooplankton, which in turn support expanded populations of fish, marine mammals, and seabirds. Picture yourself on a research cruise measuring ocean productivity during these years of transformation, using instruments that detect chlorophyll concentrations and primary productivity rates that often exceed historical measurements. The microscopic life that forms the foundation of ocean ecosystems has responded to the changed conditions with increased abundance and diversity, creating marine food webs that support larger and more diverse populations of higher-level consumers. The seasonal patterns of ocean productivity have also changed in response to the planet's axial wobble and the varying seasonal intensity that results from Earth's changing orientation. Some years bring extended growing seasons for marine phytoplankton, while others create more intense but shorter periods of productivity. Marine organisms have adapted to this increased variability with greater flexibility in their feeding and reproductive strategies, often with improved overall success rates. Fisheries around the world have needed to adapt their practices to the changed ocean conditions, but many have discovered that fish populations are actually more abundant and predictable in the transformed marine environment. Species that were once limited by tidal barriers can now access larger areas of suitable habitat, while the more stable coastal conditions often provide better nursery areas for juvenile fish. Commercial fishing operations have developed new strategies that take advantage of the changed current patterns and fish distribution, often with improved catch rates and sustainability. Picture yourself working with fishing communities that have adapted their traditional knowledge to the transformed ocean conditions, learning new patterns of fish behavior and seasonal abundance that reflect the changed marine environment. While the adjustment required significant learning and adaptation, many fishing communities have discovered that the transformed oceans provide more consistent and abundant resources than the tidally dominated seas of the past. The great ocean gyres, those massive circular current systems that dominate each ocean basin, have actually strengthened and become more stable in the absence of tidal interference. The Pacific Gyre, the Atlantic gyres, and the Indian Ocean circulation patterns now move with unprecedented consistency, creating more predictable patterns of water temperature, nutrient distribution, and marine productivity that benefit ecosystems throughout their ranges. Marine mammals that depend on these gyre systems for feeding and migration have adapted their behavior to take advantage of the enhanced stability and predictability of these massive current systems. Baleen whales can now predict with greater accuracy where they will find the concentrations of krill and small fish that support their enormous feeding requirements, while dolphins and other toothed whales have expanded their ranges to exploit new feeding opportunities created by the changed current patterns. The Arctic and Antarctic oceans have experienced particularly dramatic transformations as the absence of tidal forces allows ice formations to develop new characteristics. Sea ice that once experienced constant stress from tidal flexing now forms more stable structures that provide enhanced habitat for ice-dependent species. Polar bears, seals, and penguins have adapted to ice conditions that are often more predictable and extensive than those that existed under tidal influence. Picture yourself observing polar bear hunting behavior on Arctic sea ice that has developed new characteristics in the absence of tidal stress. The ice forms more consistent structures that provide reliable hunting platforms, while the seals that polar bears depend on for food have established more predictable breathing hole patterns in ice that doesn't experience constant tidal disruption. The transformation of polar ice has also affected global sea levels in complex ways. While the absence of tidal forces has reduced some sources of ice stress and melting, the changed ocean circulation patterns have created new patterns of heat transport to polar regions that sometimes enhance and sometimes reduce ice formation. The overall effect has been to create ice conditions that are different from but often more stable than those that existed under lunar influence. Coastal wetlands and estuaries have been among the most dramatically transformed marine environments, evolving from systems that once experienced extreme daily variations to more stable environments that support different, but often more diverse communities of plants and animals. These transformed wetlands have become critical habitat for countless species that benefit from the more consistent water levels and reduced salinity fluctuations that characterize the new coastal environment. Picture yourself walking through a transformed salt marsh that has evolved into a more stable wetland ecosystem, observing plant communities that have expanded their ranges and developed new growth patterns in response to the consistent water levels. Bird populations that depend on these wetlands for feeding and nesting have often increased dramatically as the more stable conditions provide reliable habitat throughout their seasonal cycles. The estuarine fish and invertebrate communities have adapted to the reduced salinity fluctuations and more stable water levels with remarkable success. Species that were once stressed by extreme variations between fresh and saltwater conditions now thrive in more stable brackish environments that support enhanced productivity and biodiversity. As the years continue to unfold in this transformed ocean world, the marine ecosystems continue to reveal new forms of beauty and complexity that demonstrate the remarkable creativity of life in adapting to changed conditions. The oceans sing a new song, not the dramatic twice-daily chorus of tidal rush and retreat, but a gentler, more complex melody of currents, waves, and life that speaks of adaptation, resilience, and the endless capacity of nature to create beauty from change. The great blue heart of our planet continues to beat, but now with rhythms that reflect a new relationship between Earth and the cosmic forces that shape its destiny, creating marine environments that support life in abundance, while revealing new aspects of oceanic beauty that were impossible in the tidally dominated world that existed under lunar influence. Chapter 9. Humanity's Quiet Renaissance. As the first decade without the moon draws to a close, human civilization itself begins to reflect the profound transformations that have reshaped the natural world. The changes in human society unfold with the same gentle inevitability that has characterized all the other adaptations to this moonless Earth, not through crisis or catastrophe, but through gradual shifts in perspective, lifestyle, and cultural expression that reveal humanity's remarkable capacity to find beauty and meaning in transformed circumstances. Picture yourself visiting cities around the world during these years of adaptation, observing how urban environments have evolved to harmonize with the deeper darkness, the changed coastal conditions, and the subtle variations in seasonal timing that define this new Earth. The great metropolises of the world have not been diminished by these changes, but rather have discovered new forms of beauty and functionality that were impossible in the moon-dominated world. Urban lighting design has undergone a revolution that prioritizes harmony with the star-filled night sky rather than competition with it. Cities have learned to provide necessary illumination for safety and commerce while preserving the magnificent view of the cosmos that the absence of moonlight has revealed. Street lighting now often uses warmer, more directed illumination that reduces light pollution while creating urban environments that feel more connected to the natural rhythms of day and night. Walking through a transformed city center during one of these starlit evenings feels like experiencing urban life that has rediscovered its relationship with the cosmos. Buildings are illuminated in ways that enhance rather than obscure architectural beauty, while public spaces are designed to encourage people to look up and appreciate the stellar display overhead. Parks and plazas incorporate features that frame views of the night sky, creating urban environments where cosmic awareness becomes part of daily life. Picture yourself in one of the great capitals during these years of transformation, perhaps London, with its Thames flowing more gently without extreme tidal variations, or New York, where the harbor maintains more consistent water levels that have simplified shipping and waterfront development. These cities have adapted their infrastructure to take advantage of the changed conditions while developing new cultural characteristics that reflect their inhabitants' growing awareness of Earth's transformed relationship with the cosmos. The architecture that emerges during this period reflects humanity's changed relationship with natural light and cosmic cycles. Buildings incorporate larger windows and more open spaces that take advantage of the enhanced star visibility, while rooftop gardens and observatories become standard features of urban design. Many new structures include adjustable elements that can adapt to the gradually changing seasonal patterns, creating buildings that remain functional and beautiful despite the increased variability in climate conditions. Residential architecture has evolved to embrace the deeper darkness while maximizing the benefits of enhanced star visibility. Homes feature larger windows oriented toward optimal sky viewing, while outdoor living spaces are designed to encourage evening activities under the brilliant star-filled sky. Many communities develop shared observatories and stargazing areas that become focal points for neighborhood social life and cosmic education. Picture yourself in one of these transformed residential neighborhoods, where evening gatherings often move outdoors to take advantage of the spectacular night sky views. Children grow up with an intimate knowledge of constellations and cosmic phenomena that previous generations could only dream of achieving, while adults discover that evening socializing under the stars creates deeper and more meaningful community connections than indoor activities ever provided. The transportation systems of this transformed world have adapted to the changed coastal conditions and the absence of tidal scheduling constraints. Shipping and port operations have simplified dramatically as harbors maintain more consistent water levels, while coastal railways and highways no longer need to account for regular tidal flooding. The predictable nature of the new coastal environment has actually improved transportation efficiency and reduced infrastructure maintenance costs in many regions. Maritime transportation, freed from the need to schedule arrivals and departures around tidal conditions, has become more efficient and predictable. Ports that once required expensive infrastructure to accommodate extreme tidal ranges now operate with simpler, more cost-effective designs that take advantage of stable water levels. The global shipping industry has adapted to these changes with improved efficiency and reduced environmental impact. Picture yourself observing operations at a major port during these years of transformation, watching ships arrive and depart on schedules determined by weather and cargo logistics rather than tidal timing. The simplified port operations have reduced costs and improved efficiency while creating harbor environments that are more stable and accessible for both commercial and recreational maritime activities. Agricultural communities around the world have adapted their practices to the gradually changing seasonal patterns with remarkable success. Rather than struggling against the increased variability in climate timing, farmers have learned to work with the new patterns, often discovering that the changed conditions create opportunities for improved productivity and crop diversity. The slight variations in seasonal timing have encouraged more flexible farming practices that are actually more resilient than the rigid schedules that characterized agriculture in a moon-stabilized world. Traditional agricultural knowledge has evolved to incorporate the new patterns of seasonal variation, often combining ancient wisdom about reading environmental cues with modern understanding of climate systems. Many farming communities have discovered that the increased seasonal flexibility allows for multiple growing seasons or extended harvest periods that were impossible under the more rigid seasonal timing of the previous world. Picture yourself visiting farming communities that have thrived during these years of adaptation, observing agricultural practices that have become more diverse and sustainable as farmers learn to respond to actual growing conditions rather than rigid calendar dates. The slightly unpredictable timing of seasons has encouraged agricultural practices that are more in tune with natural cycles and environmental conditions. The wine industry has adapted to the changing seasonal patterns by developing more flexible harvest practices that often result in unique and exceptional vintages. Vintners have learned to read the changed environmental cues to determine optimal harvest timing, sometimes producing wines with characteristics that were impossible to achieve under the predictable seasonal timing of the moon-influenced world. Educational systems have undergone their own transformation as children growing up in this moonless world develop different relationships with natural cycles and cosmic awareness than any previous generation. Schools have incorporated enhanced astronomy education and outdoor learning experiences that take advantage of the spectacular night sky visibility. Students develop an intimate familiarity with stellar movements and cosmic phenomena that was impossible when moonlight dominated the night sky. Picture yourself visiting a school during these years of transformation, observing children who have grown up with the brilliant star-filled nights as their normal experience. These students often demonstrate remarkable knowledge of astronomy and natural cycles, developing a cosmic perspective that influences their understanding of science, mathematics, and their place in the universe. The curriculum has adapted to include more emphasis on environmental observation and natural cycles, as students learn to read the subtle cues that govern the more variable seasonal patterns. This enhanced connection to natural systems often produces students who are more environmentally aware and scientifically literate than previous generations. Art and literature have experienced a renaissance as creative communities respond to the transformed environment with new forms of expression that reflect humanity's changed relationship with natural and cosmic cycles. Painters have discovered new possibilities in the enhanced starlit landscapes, while writers explore themes related to adaptation, cosmic perspective, and humanity's place in a universe that has revealed itself more clearly through the enhanced night sky visibility. The performing arts have adapted to incorporate the spectacular natural lighting conditions that the transformed world provides. Outdoor theater and musical performances take advantage of the star-filled backdrop to create entertainment experiences that blend human creativity with cosmic beauty. These performances often become community celebrations that strengthen social bonds while enhancing appreciation for the transformed environment. Picture yourself attending an outdoor concert during one of these star-filled evenings, experiencing music that has been composed specifically to complement the cosmic environment. The combination of human artistic expression with a magnificent stellar backdrop creates aesthetic experiences that were impossible in the moon-dominated world. Religious and spiritual communities have found new meaning in the transformed cosmic environment, often developing practices and perspectives that emphasize humanity's connection to the larger universe revealed by the enhanced night sky visibility. Many traditions have incorporated stargazing and cosmic observation into their spiritual practices, creating forms of worship and meditation that take advantage of the direct connection to cosmic beauty that the moonless nights provide. The enhanced visibility of the Milky Way and distant galaxies has inspired new forms of spiritual expression that emphasize humanity's place in the cosmic community. Prayer and meditation practices often move outdoors to take advantage of the inspiring night sky displays, creating spiritual experiences that connect individual consciousness with the vast universe visible overhead. Scientific research has experienced a golden age as the enhanced night sky visibility and changed environmental conditions create new opportunities for observation and discovery. Astronomy has benefited dramatically from the reduced light competition and enhanced stellar visibility, while ecological research has found rich material in studying how natural systems adapt to the transformed environmental conditions. Research institutions have adapted their programs to take advantage of the unique conditions that the moonless world provides. Studies of adaptation, cosmic observation, and environmental change have produced insights that would have been impossible to achieve in the moon-dominated world. The enhanced conditions for astronomical observation have led to discoveries about distant galaxies and cosmic phenomena that have revolutionized our understanding of the universe. Picture yourself visiting an observatory during these years of enhanced cosmic visibility, watching astronomers make discoveries about distant stars and galaxies that were previously hidden by lunar interference. The research conducted during this period has expanded human knowledge of the cosmos in ways that will influence scientific understanding for generations. Economic systems have adapted to the changed conditions with innovations that often improve efficiency and sustainability. Industries that were once constrained by tidal timing have developed new operational patterns that take advantage of the more stable coastal conditions. Tourism has evolved to emphasize the spectacular night sky viewing opportunities and the unique ecological conditions that characterize the transformed world. The hospitality industry has created new forms of tourism that focus on astronomical observation and natural beauty, developing resorts and destinations specifically designed to take advantage of the enhanced star visibility and transformed ecosystems. These new tourism approaches often have lower environmental impact while providing more meaningful and educational experiences for travelers. Coastal real estate and development have adapted to the more stable water levels and reduced tidal variation, often creating more sustainable and attractive waterfront communities. The absence of extreme tidal ranges has simplified coastal construction while creating opportunities for waterfront developments that were impossible under tidal conditions. Picture yourself visiting coastal communities that have been redesigned to take advantage of the stable water levels and enhanced natural beauty of the transformed shoreline. These communities often demonstrate innovative approaches to sustainable living that work in harmony with the changed environmental conditions. Mental health and well-being have often improved in communities that have successfully adapted to the transformed conditions. The enhanced connection to natural cycles and cosmic beauty, combined with the increased social cohesion that often develops as communities adapt together to change conditions, has created psychological benefits that improve quality of life for many people. The deeper darkness and spectacular night sky displays have encouraged forms of relaxation and stress relief that were impossible in the moon-dominated world. Evening activities that take advantage of the cosmic beauty overhead often provide more effective stress relief and mental restoration than indoor alternatives. Cultural traditions have evolved to incorporate the new environmental conditions, often creating festivals and celebrations that honor the changed relationship between Earth and the cosmos. These new traditions frequently emphasize community cooperation, environmental stewardship, and cosmic awareness in ways that strengthen social bonds while celebrating the beauty of the transformed world. Seasonal celebrations have adapted to the more variable timing patterns by focusing on actual environmental conditions rather than fixed calendar dates. These flexible celebrations often create more meaningful connections to natural cycles while accommodating the increased seasonal variability that characterizes the transformed world. Picture yourself participating in one of these evolved cultural celebrations, experiencing community traditions that have adapted to embrace the beauty and meaning of the changed world. These celebrations often demonstrate humanity's remarkable ability to find joy and significance in transformed circumstances while maintaining the social connections that make community life meaningful and fulfilling. As human civilization continues to adapt to the moonless world, the changes reveal not loss or diminishment, but transformation and renaissance. Humanity has discovered new forms of beauty, meaning, and community connection that were impossible in the moon-dominated world, creating a civilization that is more connected to cosmic cycles, more aware of environmental relationships, and more capable of finding joy and wonder in the magnificent universe that has revealed itself more clearly through the enhanced night sky of the transformed Earth. The quiet renaissance that characterizes human adaptation to the moonless world demonstrates our species' remarkable capacity to not merely survive change, but to discover in transformation new opportunities for growth, beauty, and connection to the larger cosmos of which we have always been a part, but which we can now see and appreciate with unprecedented clarity and wonder. Chapter 10: A New Cosmic Dance. As we approach the end of our journey through this transformed Earth, now more than a decade into its existence without the moon's gentle influence, we find ourselves witnessing the emergence of entirely new rhythms that govern life on our planet. The accumulated effects of all these changes, the profound darkness, the stilled tides, the wobbling axis, the gradually shortening days, the variable seasons, and humanity's quiet adaptation, have created a world that dances to different cosmic music, yet one that resonates with beauty and harmony that speaks to the remarkable resilience and creativity of existence itself. Picture yourself standing in a place that has become symbolic of this transformed world. Perhaps on a hill overlooking a coastline where the gentle waters reflect the brilliant starlight, or in a meadow where the changed seasonal patterns have created flower displays of unprecedented beauty and complexity. As you breathe the evening air and gaze upward at the magnificent stellar display that now dominates every clear night, you begin to understand that you are witnessing not the end of one story, but the beginning of another. The relationship between Earth and the Sun has subtly changed in ways that create new patterns of beauty and meaning. Without the Moon's gravitational influence to complicate the celestial mechanics, Earth's orbit around the Sun has achieved a kind of purity that allows our planet to respond more directly to solar influences. The seasons, though more variable in their timing, often achieve greater intensity and clarity as Earth's wobbling axis creates periods when the planet's orientation enhances rather than moderates its relationship with our life-giving star. During these years of observation, astronomers have documented how Earth's path through space has simplified in some ways, while becoming more complex in others. The absence of the Moon's gravitational perturbations has allowed Earth to settle into orbital characteristics that create new patterns of solar radiation and seasonal development. Some years bring periods of enhanced solar influence that create growing seasons of unusual abundance and beauty, while others produce more moderate conditions that support different but equally valuable ecological developments. Picture yourself as an astronomer tracking these orbital changes over the years since the Moon's departure, watching as Earth develops new relationships with the solar wind, cosmic radiation, and the subtle gravitational influences of other planets. Your measurements reveal that Earth has become more responsive to these previously minor influences, creating a planet that participates more actively in the gravitational conversations that occur throughout the solar system. The aurora displays that grace the polar regions have taken on new characteristics as Earth's magnetic field responds to the changed rotational dynamics and the altered relationship with solar influences. Without the Moon's magnetic interactions to complicate the patterns, the aurora often achieve greater intensity and display characteristics that were rarely seen in the Moon-dominated world. These enhanced light shows become regular features of polar life, creating natural displays that rival anything human artists have ever imagined. The night sky itself has become a source of wonder and inspiration that influences every aspect of life on the transformed Earth. Children growing up in this world develop an intimacy with cosmic phenomena that previous generations could never achieve. They learn to navigate by stars, to predict weather by observing stellar visibility, and to understand their place in the universe through direct observation of the cosmic environment that surrounds our planet. Picture yourself spending an evening with one of these children who has grown up under the brilliant moonless skies, listening as they point out galaxies, nebulae, and star clusters with the same casual familiarity that previous generations reserved for local landmarks. These young people often possess an intuitive understanding of cosmic relationships and planetary movements that reflects their direct experience of living in intimate contact with the universe beyond Earth. The enhanced stellar visibility has revolutionized human understanding of our place in the cosmic community. The Milky Way, now visible in spectacular detail from most locations on Earth, serves as a constant reminder that our planet is part of a vast galactic system containing hundreds of billions of stars. This enhanced cosmic perspective has influenced philosophy, religion, science, and art in ways that create more profound and meaningful approaches to understanding existence and humanity's role in the universal story. Weather patterns on this transformed Earth have developed new characteristics that reflect the changed relationship between planetary rotation, axial orientation, and cosmic influences. Storm systems often achieve different intensities and follow altered paths as the faster rotation and wobbling axis create new patterns of atmospheric circulation. Many regions experience weather that is more dramatic but also more predictable in some ways, as the simplified cosmic influences create clearer relationships between solar activity and terrestrial conditions. The jet streams, and other major atmospheric circulation patterns have adapted to the changed planetary dynamics by developing enhanced stability in some regions and increased variability in others. These changes often create more distinct climate zones and more pronounced seasonal differences that support greater ecological diversity and agricultural potential than existed under the moon's moderating influence. Picture yourself observing weather patterns during these years of atmospheric adaptation, watching storm systems that move with new characteristics across landscapes that have learned to respond to different seasonal cues. The weather often achieves a kind of clarity and definition that makes prediction easier while creating more dramatic and beautiful atmospheric displays. The ocean currents that drive global climate have achieved new levels of stability and efficiency as they operate without tidal interference. The great conveyor belt of circulation that carries heat from equatorial to polar regions now functions with enhanced effectiveness, creating climate patterns that are often more stable and predictable than those that existed under lunar influence. These improved circulation patterns have created regional climates that support enhanced biodiversity and agricultural productivity. Marine ecosystems continue to reveal new forms of beauty and abundance as they adapt to the transformed oceanic conditions. Deep-sea communities that were once limited by tidal mixing now flourish in more stable environments, while coastal ecosystems have developed unprecedented diversity and productivity. The oceans have become more transparent and accessible, creating underwater environments that support larger and more complex communities of marine life. Picture yourself diving in these transformed oceans, exploring underwater landscapes that have achieved new levels of beauty and complexity in the absence of tidal disturbance. Coral reefs extend into previously unsuitable areas. Kelp forests create underwater cathedrals of unprecedented grandeur, and fish populations achieve densities and diversity that were impossible under tidal conditions. The geological processes of the planet have also responded to the changed conditions in subtle but significant ways. Coastal erosion patterns have stabilized in new configurations, while volcanic and seismic activity has adapted to the altered stress patterns created by the changed tidal forces and rotational dynamics. Many regions have achieved greater geological stability as the constant stress of extreme tidal forces has been removed from coastal and oceanic systems. Mountain ranges and river systems have developed new relationships with the enhanced seasonal variability, often creating more dramatic and beautiful landscapes as they respond to the altered patterns of precipitation and temperature that characterize the transformed climate. Glacial systems have adapted to the changed seasonal patterns by developing new flow characteristics that often create more spectacular and accessible mountain environments. The biological diversity of the transformed Earth has often exceeded that of the moon-dominated world as ecosystems adapt to the changed conditions by developing new species relationships and community structures. Evolution has accelerated in some lineages as organisms explore new ecological niches created by the transformed environmental conditions, while existing species have often expanded their ranges and achieved greater population densities. Plant communities have developed new characteristics that reflect their adaptation to the changed light conditions and seasonal patterns. Many species have evolved enhanced sensitivity to stellar radiation and improved ability to respond to the more variable seasonal cues. These adaptations have often resulted in more beautiful and productive plant communities that support greater animal diversity. Picture yourself walking through forests and meadows that have achieved new levels of beauty and complexity as they adapt to the transformed environmental conditions. Flowers bloom in patterns that create more spectacular displays. Trees develop growth forms that take advantage of the changed light conditions, and wildlife populations achieve abundances that create ecosystems of unprecedented richness. Human culture has continued to evolve in response to the enhanced cosmic awareness and changed environmental conditions that characterize the transformed world. Art, music, literature, and philosophy have all developed new characteristics that reflect humanity's deeper connection to cosmic cycles and natural rhythms. These cultural developments often achieve greater beauty and meaning than was possible in the more predictable but less cosmically connected world that existed under lunar influence. Scientific understanding has advanced dramatically as researchers take advantage of the enhanced observational conditions and the unique environmental characteristics of the transformed world. Discoveries in astronomy, ecology, oceanography, and climate science have revolutionized human knowledge and created new technologies that work in harmony with the changed planetary conditions. The social structures that support human communities have often become more cooperative and sustainable as people learn to work together to adapt to the changed conditions. Communities that successfully navigate the transition often develop stronger social bonds and more effective governance systems that reflect the enhanced cosmic perspective and environmental awareness that characterizes life in the transformed world. Picture yourself participating in one of these evolved communities, experiencing social relationships that have been strengthened by the shared experience of adapting to cosmic change while discovering new forms of beauty and meaning in the transformed environment. These communities often demonstrate humanity's capacity to find opportunity and growth in circumstances that initially appear challenging. As you stand in this transformed world, breathing air that moves to different rhythms and gazing upward at stars that shine with unprecedented brilliance, you begin to understand that what you have witnessed is not a story of loss, but one of transformation and renewal. The Earth has learned to dance to new cosmic music, and in learning these new steps, it has discovered forms of beauty and harmony that were impossible while constrained by the familiar but limiting partnership with the Moon. The absence of the Moon has revealed Earth's capacity to develop new relationships with the cosmic forces that shape planetary existence. The enhanced connection to stellar influences, the simplified orbital mechanics, the more direct relationship with solar cycles, and the increased responsiveness to cosmic radiation have created a planet that participates more fully in the cosmic community while maintaining the beauty and complexity that make it a suitable home for life. The transformed Earth demonstrates that cosmic partnerships can change without destroying the essential characteristics that make a world beautiful and habitable. Life has not only survived the transformation, but has often thrived, discovering new forms of beauty and meaning that enrich rather than diminish the experience of existence. The planet has become more rather than less connected to the cosmic environment, creating opportunities for growth and development that were impossible under the Moon's familiar but constraining influence. As you prepare to carry the memory of this journey back to your ordinary consciousness, let the peace and wonder of the transformed world remind you that change, even cosmic change, can lead to new forms of beauty and meaning rather than loss and diminishment. The Earth you have visited dances to different music, but dances still, creating beauty that reflects the endless creativity of existence and the remarkable capacity of life to find harmony in any cosmic circumstance. The stars continue their ancient dance overhead, no longer sharing the stage with a lunar companion, but shining with enhanced brilliance that illuminates a world that has learned to find beauty in transformation and meaning in adaptation to new cosmic rhythms.